Okay, so number one, well, we've been given a lot of values, and we've been given that your function is h of x is f of g of x. And I'm trying to find h prime of 14. So first, what I'm going to do is I'm going to show the work for taking the derivative without plugging in numbers. So this is going to say h prime of x equals, take derivative of the outside, times derivative of the inside, like this. So that's going to be f prime of g of 14 times g prime of 14. Well, first we need to find g of 14. It says g of 14 is 2, so this just becomes f prime of 2 times g prime of 14. And then now these are just two values being multiplied, because this is my h prime of 14. So then f prime of 2 is 12, times g prime of 14 is 5. So then your answer, h prime of 14, is 5 times 12, which is 60. Next one, we want to determine where g, which is f of x cubed, has a horizontal tangent line. Horizontal tangent line means that your derivative equals 0. Careful, it's not f prime that's equals 0 here, it's g prime that's equaling 0, because I want the derivative of g, so we're going to find g prime, set it equal to 0. So g we are looking at is f cubed, so that means g prime of x would be 3 f of x squared times f prime of x. And then now we can just replace, this is x squared minus 6x plus 8 squared. F prime would be 2x minus 6. And we just said that we want g prime of x equals 0. So 3, right, there's no x value that will make 3 equal to 0. But if you look right here, this is going to become x minus 4 and x minus 2. So both of those values, if I were to have those, like x equals 4 or 2, would make this term 0, which then would be multiplying, making everything 0. So that's two solutions. But also, if this term were 0, right, that would make the whole thing. So the x value that makes this factor 0 would be x equals 3. So I have three answers right there that would all make the horizontal, or the derivative 0, which would mean a horizontal tangent line. We are checking continuity and differentiability. First, let's check continuity. So the limit as we approach 2 from the right of f of x. I said from the right, but that definitely is from the left. But either way, from either side. So as I come from the left, that would be 2 squared plus 3. 2 squared is 4 plus 3 is 7. And then this one would be 3 times 2 plus 2, which is 6 plus 2, which is 8. So just their limits don't exist, so it is not continuous. And because it's not continuous, I don't even need to check differentiability, because it's not continuous, it's also not differentiable, right? Step 1 of differentiable is it has to be continuous. Here we should recognize this is the limit definition of a derivative, because we've got the derivative plus the function plus h minus that function over h, and h approaching 0. So what this is saying this is the derivative of the function g. So it's the derivative of g, but it's not in terms of x. I actually plugged in a value, so that is telling me is at the value x equals 4. So then derivative of g at x equals 4 is just g prime of 4. Here, this is not the derivative of g, because it's actually the derivative of g prime. So this is the derivative of g prime at x equals 3. So then when we're finding derivative of g prime, well, that's just g double prime at 3. So that's all I was looking for there, recognizing what those would mean. Here I have 2 being multiplied, that's product rule. So the first derivative times the other one left alone, plus the first one, take the derivative of the second. So that's h prime of x, so then h prime of 4 is just going to be f prime of 4, g of 4, plus f of 4, g prime of 4. F prime of 4 is 7, times g of 4 is 2, plus f of 4 is negative 3, g of 4 is positive 3, so that's 14 plus negative 9, which is 5, yes. Here, these two are being divided, so that means I'm going to use quotient rules. So low, d high, minus high, d low. Underneath the low squared goes like this. That's what h prime of x is, or k prime in this case, sorry. So then k prime of 4 is just g of 4, f prime of 4, minus f of 4, g prime of 4. all over g of 4 squared. G of 4 is 2, f prime of 4 is 7, minus f of 4 is negative 3, times g prime of 4 positive 3, all over g of 4, which is 2, but that gets squared. So that's 14 plus 9 over 4. 14 plus 9 is 23. So then your answer is 23 over 4. The next one, so we are looking for the equation of the tangent line. Well, f prime, that means this is my slope. This is just the x value and the y value, so that's my point, 2, 3. So now you're just going to plug in y minus the y value equals slope, x minus the x value. I want to approximate f of 2.1, so that means x is 2.1. What is f of x, or the y value? So I'm going to plug in y minus 3 equals negative 1, not x, because I'm plugging in x, 2.1 minus 2. So that's negative 0.1 equals y minus 3. When you add that over, that gives me y is approximately positive 2.9. Or I guess f of 2.1 is approximately 2.9. For what value would f of c be approximately negative 1? So I'm looking for the x value now, and I'm saying this value would be approximately negative 1. So that's saying negative 1 minus 3 is negative 1, x minus 2. And then now this is negative 4 equals negative 1, x minus 2. So 4 equals x minus 2, add over, and that gives me x is 6. Alright, number 7, so we've got cosine of 4x all to the 5th power, so you should recognize this as chain rule. I actually have 3 functions. I've got f of x inside of cosine, inside of to the 5th power. So I'm going to rewrite this as cosine of 4x all to the 5th power. So that's the same thing. I just want to rewrite it because some people this will make a little bit more sense. This is my outside function, so I'm going to work outside in. So I'm going to bolt down the 5. That's going to be now cosine of 4x, now only to the 4th power. Now I need to take derivative of the inside, which is cosine of 4x. Derivative of cosine of 4x would be negative sine of 4x. And then I still have one more inside because I've got this 4x, so I need to multiply by that derivative, which is 4. So then this is my f prime, by the way. So then this is just going to become negative 20 cosine to the 4th of 4x times sine of 4x. And that would be your answer. Here I've got 2 functions being multiplied by each other, so I have to use my product rule like this. E to the x, derivative is just e to the x, keep v the same, plus, keep that the same, derivative of cosine is negative sine. So I just pulled the e to the x out and said that's just cosine minus sine, and that is my y prime. That would be your answer. Right here, so we have a function and we are trying to find the average rate of change of ft on the interval 1 to 4. So 1 to 4 is my x values from x is 1 to x is 4. When you're finding rate of change, that's just like your change in y over change in x. I think about it as f of b minus f of a over b minus a, the change in the y values over the change in the x values. So these are like my a and b. So first of all, I need to find what f of 4 is. So f of 4 is going to be 4 cubed plus 2 over 4. 4 cubed is 64. So this is 64 plus 2 over 4. So that's 66 over 4. That can be 33 over 2, and then I can't really simplify it from there. So I'll just leave it like that. And then f of 1 is 1 cubed plus 2 over 1. So f of 1 is just 3. And then now you just substitute in. So the average rate of change would be the 33 over 2 minus 3 over b minus a, 4 minus 1. This would be 6 over 2, so then that would become, is that right? Yeah, 27. 27 over 2, all over 4 minus 1 is 3, so I'm just going to say that's 27 over 6. Oh wait, no, the 3 can cancel out. It's 9 over 2. 9 over 2. There we go. Or you can leave it as 4.5, which is the same thing. Instantaneous rate of change. So instantaneous rate of change is just saying what is the rate of change at that instant. That's the derivative at that point. So I'm going to find f prime of t. Before we plug in, find the actual derivative. We'd have to use quotient rule, because we've got dividing. So low d high minus high d low. Underneath the low squared goes. So this would become 3t cubed minus t cubed minus 2 all over t squared, which is 2t cubed minus 2 over t squared. So then if I want f prime specifically at 2, that's 2 times 2 cubed minus 2 over 4. That's 16 minus 2 over 4. That's 14 over 4, which is just 7 over 2. Equation of the tangent line at t equals 2. Well, we already know the slope, right? That's the derivative at t equals 2. So now I need to know what f of 2 is. F of 2 would be 2 cubed plus 2 over 2. 8 plus 2 is 10 over 2 is 5. So then my point is 2, 5. And then now we plug in. Y minus 5 equals 7/2 x minus 2. Checking if it's continuous or differentiable. So check continuity, that would be the limit as x approaches 2 from the left of f of x would be 2 cubed plus 1. 8 plus 1 is 9. Now we check as x approaches 2 from the right. That would be 2 squared plus 8 times 2 minus 11. 4 plus 16 is 20 minus 11 is 9. So these two check out, so that means it is continuous. And then now I need to find f prime of x to check differentiability. So that would be 3x squared and 2x plus 8. And then we're going to check, is it differentiable at x equals 2? So the limit as x approaches 2 from the left of f prime of x would be 3, 2 squared. I think that's 12. Yeah. And then the limit as x approaches 2 from the right of f prime of x is 2 times 2 plus 8. 4 plus 8 is 12. So their limits are, the limits of the derivatives are approaching the same thing. So that also means that, or that means it is also differentiable. Continuous and differentiable. We are trying to find the derivative of one function divided by another. So that means I'm going to use quotient rule. So j prime of x is low, d high, minus high, d low. Underneath the low squared goes. So that is going to be g of 6, f prime of 6 minus f of 6, g prime of 6 over g of 6 squared. So let's find g of 6 and f of 6. That's easy. You just go to 6. 1, 2, 3, 4, 5, 6. And then g of 6 is this solid line, so that's going to be 2. F of 6 is the skinnier line, that's 4. Now to find g prime of 6 and f prime of 6, well, how you find the derivative from a graph is just slope. So let's look, g is this one right here. It's going down 2 and over 1, down 2 and over 1. So that's the slope of -2 for g prime of 6. And then the f, this one right here, is going down 1 and over 2. So that's 1/2, but down, so it's -1/2. And then now we're ready to plug in. That's just 2. F prime of 6 is -1/2. Minus f of 6 is 4, g prime of 6 is -2, underneath g of 6 is 2 squared, so that becomes 1 plus 8 over 4, so that's 9 over 4, that's a negative, yes, so that was actually 7 over 4, whew. So that is j prime of 6. Number 12, I should have given more room on this, okay. Let me grab a piece of paper. Number 12, we have a function inside of another function, but then that is being multiplied by another function. So I'm actually going to use product rule and chain rule for this. So what I did is I labeled the first function, the x, as my u right here, and then this one as my v. So because it's product rule, I know I'm going to do u prime v plus u v prime. Now u prime gets a little bit complicated because I've got nesting functions, so I'm going to go off to the side and say, okay, u prime, or v prime, sorry, is just this guy right here. Bring the 4 down, 4x squared plus 5, that's now cubed, and I'm going to need to multiply by derivative of the inside, which would be 8x. So that's just 32x times 4x squared plus 5 cubed. And then now I can plug in u prime, derivative of x is just 1, times v, which I'm not doing anything to, plus u, which is just x, times times the b prime, which we just found, 32x 4x squared plus 5 cubed. Now this is absolutely correct. This is my f prime of x, but none of my answer choices look like that. In fact, all my answer choices are like the factored version, not like the like separate terms. So what I'm going to do is I notice these both have 4x squared plus 5 terms. This one has 4, this one has 3. So what they have in common is the cube to the power of 3. So I'm going to pull out 4x squared plus 5 cubed. And then what I would be left with is 1 4x squared plus 5. So 4x squared plus 5. And then I took away all of this, but I still have x times 32x, which would be 32x squared. And then these two can combine, that's 36x squared plus 5 times the original 4x squared plus 5 cubed that I just pulled out. So then your answer choice was A. Number 13, dividing, so we're going to use quotient rule. Low derivative of 1 over, or natural log of x is 1 over x minus high d low derivative of x is 1 over low squared. X over x, that's just going to cancel out, so that's going to be 1 minus natural log of x over x squared. Equation of the tangent line, so I find my derivative first, so f prime of x is 2x minus 2, so then derivative at 2 is 2 times 2 minus 2, 4 minus 2 is 2, so then that is my slope. And then I need to find my point, so just f of 2 would be 2 squared minus 2 times 2 minus 3. That's 4 minus 4, so it's just negative 3, so then 2 comma negative 3 is my point. And then now I plug into point slope. Y minus 3, which becomes, or y minus negative 3 becomes y plus 3, equals my slope, x minus 2. Just double check I haven't put anything wrong. Okay. Agrees with my answer key. Okay. Finding the values of a and b that make it differentiable. So remember, step 1 to being differentiable is it has to be continuous. I want to make the limit on either side of this equal. So as f of x approaches 1 from the left, well, that would be a times 1. I want to make that equal to the limit of f of x as I approach 1 from the right, which would be b times 1 squared plus 1 plus 1. So I have a equals b plus 2. Now, that only makes it continuous. To make it differentiable, their derivatives would have to be equal. Derivative of ax would just be a. Derivative of this would be 2bx plus derivative of x is just 1. So then their derivatives have to be equal on either side of 1. So this would be a equals 2b1, extra parenthesis, plus 1. So a equals 2b plus 1. And then I found the easiest thing to just substitute a in, like this. So I've got b plus 2 equals 2b plus 1. Subtract the 1 over, subtract this over, that gives me 1 equals b. So then I get that b equals 1. And once I have that, then you can just plug in right here to get your a. So then a would be b, 1 plus 2, so then a would be 3. So those are your two values. Calculating the derivative. So first of all, I need to have the limit as h approaches 0. It needs to be over h. I'm not asking at a point, so I'm going to have minus f of x. F of x in this case is this, so I should have minus 2x squared plus 4, all in parentheses. And then I should have the same thing, f of x, but instead of x, I need to replace it with x plus h. So that'd be 2x plus h squared plus 4 minus the whole function. So then all of these are over h. These two don't have the limit, so I can cross those off. Both of them have like minus f of x, so then now it's just, did I replace the x with x plus h? Here it's replaced. Here I have x squared and then a plus h at the end. No, I need to replace the x with x plus h, so C is the correct one. Here we would use chain rules, so h prime of x would be f prime of g of x times g prime of x. And that would be f prime, this is h prime of 3. So that would be f prime of g of 3 times g prime of 3. G of 3 is just 4, so this is f prime of 4 times g prime of 3. F prime of 4 is 8. G prime of 3 is negative 5, so that gives me negative 40. Derivative of this, so I'm going to rewrite this. This is sine of x to the 5th cubed. So when I take the derivative, I start with the outside. So bring the power down. That's sine of x to the 5th squared now. Times derivative of sine x to the 5th would be cosine x to the 5th. And then because I still have this inside function, I have one more chain. So that would become times 5x to the 4th. So then just to clean it up a little bit, this is 15x to the 4th. Sine squared of x to the 5th, cosine of x to the 5th. And that's your answer. Here, this one is sine of 3x all to the 1/2 power. So then when we take the derivative, this is your f prime of x. When we take the derivative of h, I'm going to bring down the 1/2. And now this sine of 3x is going to be to the negative 1/2 power because I subtract 1. Times derivative of sine is cosine, and then derivative of 3x is times 3. So this would really just be written as 3 over 2. I still have the cosine 3x on top, but this is negative, means it goes on the bottom. 1/2 means the square root, so that'd be square root of 2, sine of 2x. That would be my answer. I'm taking the derivative of natural log of e to the 5x. So derivative of natural log means 1 over times derivative of this, right? And then I still have a function, so times 5. This cancels out, and I'm just left with 5, which is d. You also could have said natural log and e, like, cancel out, so that would just leave me as 5x, and the derivative of 5x would just be 5. Here we're trying to find derivative of this function, so h prime of x would be, we're going to use chain rule. I've put a lot of chain rule in here. Okay, so this is h prime of 1 would be f prime of g of 1 times g prime of 1. So first I need to find what g of 1 is. So g of 1, oh no. Let's say g of 1. At 3? 1, 2. Oh yeah, it looks like it's 8. Sorry, this is kind of a crappy graph we got off the internet. Let's assume that's it at the intersection. G of 1 is 3. So this is really f prime of 3 times g prime of 1. G prime of 1 is just the slope here. It's going down 1, 2, 3, 4, 5, 6 over 2, so that's a slope of negative 3. And then f prime of 3, so we're looking at f, 1, 2, 3, so the f prime right here is going down 1 in 1, 2, 3, 4, so that would be negative 1/4. So then you just answer, negative 3 times negative 1/4 is positive 3/4. Another limit definition here, I'm given the limit definition of the derivative, and I want to know what function are we taking the derivative for and at what point, because I actually don't have an x. So you can think of this kind of as like your 2x plus h cubed minus x plus h over like the whatever minus the f of the value over the h. So when I looked at this, and all I did is I said, okay, wherever I had plus h, that was an x value. So that tells me that I'm looking at x equals negative 2. That's the value I'm looking at. And then the function I'm looking at is 2x cubed minus x. So f of x equals here, and then that's x equals negative 2, so that's like c is negative 2, because they're saying the value, what value c are we looking at. So these are my answers. F double prime, so this is easy. You just find the first prime, so that would be 4x cubed minus 16x. F double prime is just the derivative of that, so that would be 12x squared minus 16. Answer. Equation of the tangent line, so f prime, that would be my slope. My point would be 4, 5, yeah. And then it's just my minus the y value, slope times x minus the x value. Answer. We've got hours, we've got the number of ducks that have crossed the road, and we want the rate that they're crossing the road at 1:30, which is t equals 4.5. So I want to know what rate are they crossing. Let's think about, in this 1 hour, we just had 9 ducks cross. You can also just think of it as like your average rate of change or your slope. So I'll put average rate of change because we are looking for a rate. And it's not like I can find the instantaneous rate because I only have like the points. So that's just going to be f of b minus f of a over b minus a. So that's going to be 21 minus 12 over 5 minus 4. So that's 9 over 1, so, and it's positive 9, so that is a positive 9 ducks per hour. And I know it's ducks per hour because this was number of ducks. So 9 ducks over the 1 hour. Right, we are trying to find f prime and simplify as much as possible. So I would use product rule because these are multiplying. This is my u, this is my v. So u prime equals 2x, v prime would be 2x minus 5 times derivative of the inside, so that would be 4 times 2x minus 5. And then now we're going to do u prime v plus uv prime, 2x minus 5 squared plus u times 2x minus 5. How did I simplify this? Oh, I looked and I said 2x minus 5 is in both of these, so I'm going to pull the 2x minus 5 out. That would leave me with 2x times the other 2x minus 5 that got left behind. And then here I'd be left with the 4x squared. And then this just becomes 4x squared minus 10x. And then I'll rewrite it. 4x squared minus 10x plus 4x squared would become 8x squared minus 10x. And then this would be my f prime. Average rate of change is just, oh, that doesn't look like words. The change in y over change in x. So first I found f of 3. That'd be 3 to the 4th minus 8 times 3 squared plus 2. That would be 8 times 9 plus 2. 8 times 9, ooh, is 81. No, I was right. 73, no, 72. Wow. Okay, 3 to the 4th is, 81? Yeah, because it's 9 times 9. So that's just minus 70. 81 minus 70 is just 11. Whew, a lot of months. Wow. F of 0 is easy. F of 0, these would go away, is just 2. So then when you plug in, this is going to be 11 minus 2 over b minus a is 3 minus 0, which would just be 9 over 3, which is 3. Here I want the instantaneous rate of change when x is 2, so that's just f prime of 2. So f prime of x is just 4x cubed minus 16x. And then f prime of 2 would be 2 cubed minus 16 times 2. That's 4 times 8 minus 32. 4 times 8, oh no. Oh yeah, okay. Is 32 minus 32 equals 0. Thought I did it wrong, but the answer is just 0. Oh man, that's a lot of charts. Okay. Here we are looking for inverse, so j prime of x equals g prime of f of x times f prime of x. I'm looking specifically at -1, so this is g prime of f of -1 times f prime of -1. F of -1 is 0, so this is g prime of 0 times f prime of -1. G prime of 0 is 4. F prime of -1 is 2. So then your answer is 8. I don't know why I put you there. Here we are taking the derivative of k. This is going to be a chain rule. So k prime of x equals 3 f of x squared times f prime of x. So that's going to be 3 f of 0 squared times f prime of 0 if we're looking for k prime of 0. F of 0 is -1, so 3 -1 squared times f prime of 0 is -2. So that would just become 1, so 3 times -2 is -6. Here we are going to use quotient rule, so low d high would be cosine minus high. D low is f prime of x. Underneath the low squared goes. That's just your generic j prime of x. So j prime of 0 is going to be f of 0 cosine of 0 minus sine of 0 f prime of 0 over f of 0 squared. If you look at your 0, sine is 0, cosine is 1. So this term goes away because it's 0. This is just 1. F of 0 is negative 1, so it's negative 1 times 1 over negative 1 squared. That becomes positive, so you have negative over the positive is just negative 1. D, we've got product and chain rule. So think of x as like your u, this one is your v. So u prime is just 1, v prime is f prime of g of x times g prime of x, just like we've been doing on like the 4 chain rules I've given you. So then now we're going to do u prime v plus u v prime. That would be 1 f of g of x plus u is x times v prime is f prime of g of x times g prime of x. And then now, that is, we're looking specifically at h prime of negative 1. So that's going to be 8f of g of negative 1 plus negative 1 f prime of g of negative 1 times g prime of negative 1. G of negative 1 is negative 1. Great. F of negative 1 plus negative 1 f prime of negative 1 times g prime of negative 1. F of negative 1, oh no, f of negative, oh yeah, g of negative 1 is negative 1, just kidding. F of negative 1 is 0, so this one is 0 plus negative 1, f prime of negative 1 is 2. G prime of negative 1 is 1. So then this is just 0 minus 2, which is negative 2. Here, again, product rule. So u prime, e to the x is just e to the x. V plus e to the x, the next one prime. So that's what m prime of x is. So then when I do m prime of negative 1, that's going to be e to the negative 1, f of negative 1 plus e to the negative 1, f prime of negative 1. F of negative 1 is 0, so that goes away. And f prime of negative 1 is 2, so this is e to the negative 1 times 2. So this one is just 2 over e. You can leave it as e to the negative 1, but that just means over e. And then lastly, this is the limit definition of the derivative. So this is saying the derivative of g, because I'm asking of g, but it's not just g of x. It's specifically at x equals negative 1, so that's just g prime of negative 1. In the same way, we wouldn't leave our answer as this, right? We want a value, so we're going to look at the table. What is g prime of negative 1? G prime of negative 1 is positive 1, and that would be my answer.